If you've been wondering how AI voice agents actually work, well, this video is for you. I've been getting more and more questions about how agents work, how they can make them more reliable, consistent, and scalable. So if you've had all these questions hovering over your head too, well, welcome to this one because this will be a good one. Now, let me start off by saying that voice AI is no magic at all. It's just a pipeline of a lot of different moving pieces that work together as one to produce human-like speech in less than 1.2 to 1.5 seconds, right? Now, where do we start? We start with the user, you or the contact. And when a phone call starts, a human will say something like, "Hi," or "Who's this?" or "Hi, this is John." And the most important thing is that this will initiate the whole pipeline. First, we'll have a speech-to-text engine or module. This one is responsible for translating everything that it hears into text. So that's why it's so important to have the bleeding edge, having the most advanced models taking care of this initial part, because if you mess up the beginning, odds are all the rest will be messed up too, right? So there are so many different options out there that you can pick and choose from, and some have it in-house, others work with third-party vendors, and you will hear about names like Deepgram, like Artesia, and others where you can dive deep and gather more information on it if you're interested in that. Now, once it converts the audio into text, now there are a couple options. Depending on how advanced the system is, it might, one, feed that text into a RAG system or straight into the LLM. Usually the way we do it at Nedzo, by the way, is we feed it into both. So we send it to the RAG module, which stands for Retrieval Augmented Generation. Essentially, think of it like an extension of the large language model, like the brain, where you can give additional context. And what happens is, we'll go through the RAG system, we'll check, is there anything context-wise that would make sense to pass on to the large language model, the main brain, or not? If there isn't, well, no harm, no foul. There is, we'll send additional context, hitting the large language model and give them, hey, this is important for context. Please take this into consideration before elaborating your response. Good example is if I pick up the phone and say, "Hi, this is Dennis, who am I speaking with?" This will send it, of course, convert audio into text. Text then will go into the RAG system. And if I have, for example, a greeting policy in my RAG system, well, it will send that information to the large language model and say, "Hey, this is a greeting policy. Give the example." Then we'll feed also, "Hi, this is Dennis, who am I speaking with?" all at once. Now the large language model has enough information to actually elaborate a proper, intelligent response. Once that's done, it will push that output to a text-to-speech engine. You might have heard about Play, HT, 11 Labs, Artesia, and others. There are so many others out there that you can pick and choose from, and some of them even do it in-house. Now, the most important thing is, of course, that in each or every step of this chain, that nothing gets broken. Otherwise, you can see it's very sensitive and prone to error. It's like the telephone game. If someone starts like missing some details, it will completely mess up the whole sentence and the whole point and the whole result. Now, once that's done, of course, that text-to-speech engine will essentially say it out loud in a human-like way what the large language model in combination with the RAG system generated. And then it will say it out loud to the customer, so then it can, or to the user, so that they can continue the conversation. Now, this is the basic, right? And I hope this makes sense. But this is not the whole story. Reality is there are a lot more variables to it. You have enough turn detection, just understanding when the customer or the user on the other side actually finished their thought. Because this is different between, I call them dumb end of turn detections and smart. Some even call it smart endpointing. But essentially what it is there's a little mini brain that interprets and understands, hey, is this sentence complete or does it sound like it's missing? If I say something like, well, I'm looking to, even if I pause for 1 second, this shouldn't trigger a good model or a good AI agentic voice system shouldn't trigger the agent to respond right away. It should be clever enough to understand, oh, wait, it doesn't sound like they finished their sentence. So let's wait a little bit longer, right? Dumber systems rely on time instead. They can set a timer between like 1 second, less than a second, a little bit more than a second. And if it doesn't hear anything, well, it will just start generating the response. Now, on top of that, you also have the part where what if the AI agent already elaborated the response and mid-sentence, the user interrupts him, right? Which is interruption patterns, which is called VD or barge in, is super important. Because this is what makes it sound human, which is if the AI agent say, hey Dennis, I'm reaching out because, and say, oh, wait, what is the name of the company? And if it keeps going and going, it will make me feel like I'm not being listened to, where a human would naturally pause. So that's why you need the barge in and the VAD. And all of this must happen in less than 1.2 seconds. This is the most interesting part of this whole thing. Once you start going into additional and starting to elevate the level of voice agents, you'll start understanding things like which choices of the speech to text, from streaming, batch, punctuation, accents, also the turn engine. Is it system prompt? We'll use tools and functions, the state, and also even for the RAG, there's so many different components like chunking, the grounding, hallucination control. And why am I putting this out there? Well, I believe that most people understand the basics, the concept of, oh yeah, it's text to speech, or in this case, it's speech to text. Text goes to the LLM, LLM goes to text to speech, and now it works. So I can build my own. And this is why I see such a drastic difference in pricing out there. Let's see some charging 5, 6, 7, 8, 9, 10 cents per minute, and you see others charging 15, 16, 17, 18, and more. Now, I'm not saying that one is right and one is wrong. It's just like you get what you pay for. Some, of course, the more control and the more advanced and human-like the AI agents sound, the better results they will produce. But also the more expensive they are. That's also why speech-to-speech is not a reality just yet, and also because there are some additional caveats. Now, before I keep going, in the middle of all of this, you also need to think about tools. So now that we understand the voice AI engine and some of the additional nuances or variables that we can add in to make it even better, now you get to the tools section, which is what tools can I give to my agent to use throughout the call? Some very common are giving them appointment booking tools, which is give them access to a scheduler where they can look up the availability, and then they can present some slots and then schedule the appointment, or perhaps transferring a call, or updating a CRM system with new information, all while on the call. Well, this is fantastic, but remember, the more tools, the more variables you have going on. And it's important that all of these things that happen on the back end, usually they are in a form of, even if masked, they are in a form of an API call that happens in a couple milliseconds. And everything needs to be in sync. That's why voice AI is one of the most challenging channels in the conversational AI to pull off the right way. Well, lastly, how can you make sure that you have an AI agent that is consistent, scalable, and knows how to properly handle errors or problems? Well, one, double check all the connections. Make sure that you have every single tool that you give them, whether it's appointment booking, book calendars, call transferring tools, if you give them database updating tools, and more. Make sure they are all working well, they are properly set. Two, this is where I can't stress this out enough. Building an AI agent is very quick, especially with the right tools. At Nedzo, you can build them in less than 3 minutes. Real talk. Now, the key thing is you properly test them. So testing them by calling yourself, calling a small batch of numbers, or doing all stress testing the agent, making sure that it's not hallucinating, making sure that all the tools are working, making sure that the beginning and also the ending of the call is sound exactly how you want it to sound. make sure that how you capture information is correct and that everything is connected to the right system, so when the call ends, then you can, of course, take that as context to trigger additional functions. And then launch a 24-hour pilot plan, like 20 to 50 test calls. And of course, have a checklist where you can go through everything and making sure that it ticks all the boxes. Well, this video was mostly about how voice AI agents work on the back end. I'm doing some more live breakdowns very soon. I'm dropping more videos around how to build agents for different use cases, how to trigger different tools, how to make advanced actions possible. So if you have any area or any use case that you would like me to break down, well, leave them in the comment section below. I'm more than happy to break them down step by step, make a video about it, so you can essentially copy paste, build and deploy it on your end. Well, keep being awesome. Catch you in the next one.